And I promise I won't talk about Blackboard at all on Wednesday. I promise. Please! Say that again.
Oh, no, I wasn't raising my hand. I was stretching.
Oh, just stretching. Oh, okay, good. Stretch away. Let it go. Yes, good. Let me crack this over here. There's my TI. Let's get the term back on. So, I gave you that wonderful little booklet. Everybody got a scatter plot?
Yeah.
So I gave you that wonderful little booklet. And it is pretty wonderful because it has how to get the scatter plot, how to enter the data, how to rescue your lost lists, all that wonderful stuff. However, it doesn't teach you how to do a quadratic model. It teaches you how to do a linear one. So I'm faster. Except even in the margin of it, you can write down how to do a quadratic one because it's almost identical. So go to the part where it says how to do a linear regression. Somewhere in there, it's about the linear regression. I forget exactly what the phrasing is. Performing a linear regression. So go to step 3. Go to step 3 for me on that one. And if you go to that step 3, it says go to the stat, arrow over to the stat calc menu. Yes?
Yes.
So you're going to press stat. You're going to arrow over to calc. Now at this point, the booklet guides you to go to number 4, which is linreg ax plus b. Guess where you're going to go instead? Hells yeah, you're going to go to quadrag, which is number 5. Now Josh, yours is actually called P2 reg. On your 86, it's called something a little bit differently. So when you're in that menu, instead of linreg, whatever it says, LINRG, you're looking for P2 REG. Okay? So we're going to go down to quadrag instead. La, 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 la. And you're going to select that. I would still drop the y1 after it. Because if you put the y1 after it, it'll then dump the equation into y1. Just like it did for the linear regression.
How do we do that again?
Let's do it together.
Okay.
Let's do it together. Press the vars button, which is right here. See it right there under my finger? Well, actually, mine looks like VS because I've worn off the damn type. Right here. Vars. Over to y vars. Enter. Enter. And now it looks like this, quadrag y1. That's the same as it is in your booklet. I think it's on page 4, first paragraph. It actually walks you through that. The only thing that's different is it says quadrag instead of linreg in front of it. Yeah. Oh, wait, time out. I can fix that. Yeah, there's a bug. Let me fix that for you. Yeah, let me turn that bug off. Make it look exactly this. Off. We got 2. We'll fix it, Sumi. Don't you worry. There you go, Josh. We'll fix this, Sumi. Bug, be gone. There you go. So now we go. You got it. You got it. It's one of those issues they didn't fix. There we go. Ashley, yours looks weird too?
Yeah, I'm getting error.
Why is that?
Did I push it wrong button?
I think you ran a linreg instead of a quadrag. What you got?
Did you say yours too?
Oh no, you gotta put quadrag y1. Not just y1 by itself.
I put quadrag. I did. Me too.
Right, but you gotta do it all at once. Quadrag, then y1. Make it look, if you have your booklet, make it look like that, but quadrag y1 instead. Yep, now press enter. There you go, there it is.
Get the schedule. Okay.
Where's your... There it is, and the equation will come up with it. All right. Where was the error? I thought there was one more error.
Oh, we got hers.
Oh, we got it?
Yep.
Thank you, Amber. Okay, I'm ready to hit enter. I think. Here I go.
I'm lost.
Here it comes. Uh-huh. Now, that's okay. That's called a correlation coefficient. You can just ignore it. If anybody's TI is showing an R and an R squared value at the bottom, that's totally fine. That's 244 stuff. And if you take a 244, we'll play with it then. But you can ignore it for right now. I can also turn it off if you want me to after class. You can always just ignore it. So what you now have are the 3 values of the equation y equals ax squared plus bx plus c. A is 2.2. If you think back to my Excel spreadsheet, let's see if it's still, I think it's still there. Do you remember, hang on, let me close this off.
No.
Remember these numbers right here? 4.42? Do you see the relationship between that number and the first number there, that 2.21-ish? Yes, it's half. That's predictable. Well, the 4.42 is double. The 2.21 is half, potato, right? The number on my spreadsheet is twice that number, and that number is half the spreadsheet's number. That is not coincidental. That has to be there, and it has to be there because that's the number that's tied to gravity. Pretty badass. Pretty badass. Amy, go ahead.
Can you show the spreadsheet again, or the,
I'll go back to the spreadsheet, I will.
talking about?
Oh, right now, just press graph, friends, press graph. You should see the equation kind of following those points pretty damn well, huh? Pretty damn well. Pretty neat. Because gravity was pulling me down the hill. Gravity was pulling me down the hill. FYI, I borrowed this example from somebody who used to do it with a rolling van. This is before the days of litigiousness. They put a student in a van with them on that same hill. Call 1, 2, 3, go, cut the parking brake with a student next to him, and then you guys are standing next to the thing, clang, 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 with an empty van not started. I don't know how nobody died doing that, so I like the bike, it's a little bit safer. But what's cool is, though, it doesn't matter if it's a van or a bike. That doesn't matter. The speed changes a little bit because of the mass, because it's rolling downhill, pulling the mass. But the acceleration is identical. That's what's so cool. The acceleration is identical. Totally rad. Okay, so far?
Yeah.
With me so far? Okay. Now, the equation is going to look a little bit messy. If you press the y equals button on your TI and take a look at it, it's a little bit messy. It's a bit messy, yes. It is definitely messy. I'm going to go ahead and I'm going to crank it on the board right next to this. I'm going to slide this down a smidge. Okay, because I don't want to get too far away from that equation, because that equation is going to help us answer everything, including how fast I was going at 200 feet.